Now we have to understand the effect of temperature on semiconductor. So we have seen that electrical conductivity of a semiconductor changes with temperature variation. So we are writing that the electrical conductivity of a semiconductor changes with the change in temperature. If there is a variation in the temperature, the properties of a semiconductor will going to change. So therefore, we have to define the effect of the temperature on a semiconductor. So first we will going to talk about the absolute zero. Now when we are talking about the absolute zero, what we are saying that at absolute zero temperature, all the electrons are tightly held by the semiconductor atoms. That means we are trying to say that the inner orbit electrons are bound. Okay, so we have seen that when we are talking about the semi orbit configuration, we have seen we have got a inner orbits and the valence orbit. Okay, where the valence electrons are present. Okay, so when we are talking about this, we say that inner orbit. In inner orbit, electrons are bound. Okay, they are very bound with each other, okay, with respect to the nucleus, okay, whereas when we are talking about the valence electrons, they are being engaged in the covalent bonding with their neighbors. Okay, so we are writing that whereas valence electrons are engaged, or we can say associated with the covalent bonding. Therefore what we can say is that this is important because we are they are associated with the covalent bonding, and we are talking about the absolute zero. Okay, so at absolute temperature, these covalent bonds are very strong. Okay, and therefore there are no free electrons available. So we are writing so at absolute temperature, these covalent bonds are very strong, and therefore there is no free electron. And I am highlighting this no free electron. Okay. So what this no free electron means, it will going to make it as a perfect insulator. Okay, because they will not be able to conduct. Okay. So hence, okay, so I'm writing this no free electrons, and because of this no free electrons, what we can say, hence we can say that the semiconductor material, or we can say the semiconductor crystal, behave as a perfect insulator. Behave as a perfect insulator. Now, let's talk about the effect of a temperature above absolute zero. First, we have to understand that what happens when we are talking about the semiconductor at a room temperature. So, when we are talking about the semiconductor at room temperature, what we say that when the temperature rise, okay, so some of the covalents bond in the semiconductor breakouts, and this breaking of a bond is due to the thermal energy supplied to the semiconductor material. And when these covalent bonds break out, it will going to create a free electrons. So we can say the breaking of a bonds will going to set those electrons free, which are engaged in the formation of these covalent bond. And this property we have already seen when we have defined the properties of a semiconductor. So we are writing semiconductor has got a negative temperature coefficient of a resistance. The negative temperature of a coefficient means that the resistance of a semiconductor decrease with the increase of a temperature and vice versa.